Okie dokie. This lesson is on composition and inverses of functions. And actually, it's not on inverses at all, it's just compositions. Inverses is a whole other section, so you can just scribble that. Composition, of functions. There we go. Composition of functions. What it is it's given, say I'm given f of x and g of x. It wants me to find each function below. Now, the way that I do that, it says f of x, f plus g is really just f of x plus g of x. That's all that means. So I replace f of x with x plus 3, because that's what f of x is, plus g of x is 2x over x minus 5. And I have to add these together. That is not, this is wrong. Don't write this down. I repeat, don't write this down. This is in red because it's wrong. This is wrong. Wrong. Even more wrong. I don't know what that is. Don't do that. That's completely wrong. Okay? If you were watching this without sound, you're probably pretty confused on what I just did there. So, some people watch it without sound. That's just nuts. Anyway, what you have to do is x plus 3 is one thing, so it's over 1. And 2x goes with the x minus 5. So what you have to actually get is a common denominator. Now, the common denominator is what would 1 and x minus 5 both go into? Well, 1 will go into x minus 5, but x minus 5 will not go into 1, so x minus 5 is my common denominator. So what I do, if you just kind of go back to Algebra 1 for a second, not Algebra 1, like 5th grade or something, I don't know. Say I was adding 3 over 1 plus 2/5, okay, and we said our common denominator was 5. What would we do? Well, we would say 1 goes into 5 times, so we would say we multiply the bottom by 5. Anytime we do something to the bottom, we also have to multiply the top by 5. 5 times 3 is 15, and then this one did not change, so it's still a 2, and then you add the numbers across the top. 15 plus 2 is 17 over 5. Well, I'm going to do the exact same thing down here. I say, well, what do I have to multiply by 1 to give me x minus 5? Well, x minus 5. If I do it to the bottom, I also have to do it to the top. Now, I'm going to have to FOIL that out. Now, I noticed on our last quiz, we were a little iffy on foiling, so I'm going to kind of go back through that again. To FOIL, you do first x times x is x squared. Outer x times 3 is 3x. Inner negative 5 times x is negative 5x. I don't have enough room. Dang it. And last would be negative 5 times 3 is negative 15. Trapped. And then the 2x, you just bring him down. He just hangs out. We're going to go ahead and combine like terms. The 3x and the negative 5x would add together to give me negative 2x minus 15 over x minus 5 plus, I can't write straight, I'm sorry, I'm very crooked. And then what you would do is, when you're getting a common denominator, how about I try to write straight? That'd be great. The denominator stays the same, and you just combine everything on the top. So x squared minus 2x minus 15 plus 2x. And then you combine like terms again. The negative 2x and the positive 2x would add together, and they would cancel out. So you would wind up with x squared minus 15 over x minus 5. Now please note, you cannot cancel the x with this x squared here and this 5 with this negative 15. The rule is you can cancel factors, not terms. So if I had x plus 3, this is not part of this problem, don't write it down, x plus 3 and x minus 5 over x minus 5, you could cancel that, and it would leave x minus 3. But you cannot cancel across that minus sign and get x minus 3. You leave it. That is your answer. It is done. I'm not sure what just happened. I don't know what just happened. I don't know. It got really small. Okay, that's too big. Sure, that's good enough. Okay. So it's x minus 5. The only thing that you have to say is the domain here, x cannot be 5 because the bottom cannot equal to 5. Okay, so this one is going to be very similar except for we're subtracting. So, and let me check something really fast. Okay, I'm just making sure my microphone was working. Sorry. Sorry if that was loud in your ear. I apologize. F of x, so this is f of x minus g of x. So f of x, again, is x plus 3, minus g of x is 2x over x minus 5. So I'm going to get a common denominator. This is basically the same problem. The denominator would be x minus 5. This one, I multiply x minus 5 on the bottom. Anything you do to the bottom, you have to do to the top. We have already folded that out one time. It ended up being x squared minus 2x minus 15. And then, this time, instead of adding 2x minus 15 minus 2x, I'm subtracting. So negative 2x and negative 2x is negative 4x, so it's x squared minus 4x minus 15 over x minus 5, where x cannot be 5, because that's where the bottom equal to 0, and you can't do that. C and D are a little bit easier. C, I'm multiplying, so it's f x plus 3 times g 2x over x minus 5. Now when we multiply fractions, we go straight across the top, straight across the bottom. So we would do x plus 3 times 2x over x minus 5. And I would just distribute. 2x times x is 2x squared plus 2x times 3 is 6x. And again, x cannot be 5. And I have to blow my nose. So we're going to pause. And I'm back. Or you're back, whatever. Okay, so now we're doing f x plus 3 over 1 divided by g 2x over x minus 5. Now, when you divide fractions, you actually multiply by the reciprocal. Now, that means you leave the first one alone, and you flip the second one. And you go straight across the top, straight across the bottom. Now, on the top, you have to full. That's going to be x squared minus 5x plus 3x minus 15 over 2x, which ends up, if you combine like terms, being x squared minus 2x minus 15 over 2x. And this time, the bottom, the 2x, can't be 0, so that means x can't be 0. So that's actually part of your answer. The name all values of x that are in the domain of the new function. This one, considerably easier. There's no fractions. No fractions. Life is good. So it's just f plus g. So 2x plus 1 plus x squared. And just put it in order to make it look pretty. X squared plus 2x plus 1. Now, does it have a domain issue? Well, does it have a bottom? No. Does it have a square root? No. So all real numbers. F minus g, you would do 2x minus 1 minus x squared. So it would be negative x squared plus 2x minus 1. No domain issues, so all real numbers. F times g is 2x minus 1 times g. I don't like the way that's written. I'm just going to put it in the front. And then I distribute, so that would be 2x to the third minus x squared. No bottom, no square root, all real numbers. F over g would be 2x minus 1 over x squared. This one has a domain issue. The bottom cannot be 0. If I take the square root of 0, x cannot be 0. And the last thing is the composition of functions. That's f of g. And that's supposed to be an of. F of g, not a dot, because dot's times. It's f of g. And what it is it's f of g of x. That means I put g inside of f. So if I want f of g of x, I'm going to take the g and put it inside the f where the x is. So instead of x, I write 1 over x minus 1, and then plus 1, because that's the rest of the problem. Whoops, that's the same color. So what I've actually done is I've replaced the 1 over x minus 1 where the x was, and then I work the problem out. Now guess what I have? I have fractions. Yay. So I'm going to have to get a common denominator. So this is 1 over x minus 1. 1 is 1 over 1, so that's a fraction, right? So I get a common denominator. My common denominator would be x minus 1. The first one did not change. It's the same thing sorry, my microphone was about to fall off the table. From here to here, so that's a 1. This one, for the bottom, I multiplied the bottom by x minus 1. If I do it to the bottom, I must also do it to the top, so that's going to be x minus 1. And then for fractions, I leave the bottom alone, and I combine the top. 1 plus x minus 1. Well, the 1's cancel out, so I wind up with x over x minus 1. And it has a domain issue. The bottom cannot be 0, so x cannot be 1. So this is my answer. And I'm going to go over a bunch of these tomorrow. We're going to basically practice all these tomorrow, because a lot of times I've learned that y'all have a hard time with the f of g and the g of f because you barely hit it in, hey, I'm missing a f of x here. Let's make f of x x minus 2. Sure. So I want to find g of f of x. So I want to take what my inside function is. My inside function is my f. So I'm going to take my f, my x minus 2, and plug it into the g where the x is. So it's just going to be 3 times f, but f is x minus 2. So it would be 3x minus 6, and it doesn't have any domain issues. I'm going to go ahead and work a couple of these. It asks me to find f of g, g of f, and then f of g of 4. I'm just going to do the first one, take it to a new page because I don't really have enough room. And then we'll go over a good many of these together. I want to find f of g of x. F of g of x means I take the g. G is my inside function here, and I'm going to put it inside of the f where the x is. So it'll be 2 times the x, but the x is x squared minus 2x minus 4 plus 1. And then I work it out. 2x squared minus 4x minus 8 plus 1. 2x squared minus 4x minus 7. Now for g of f of x, it's going to be a little different. G of f, what's my inside function this time? The f. So I'm going to take the f and plug it inside of the g where the x is. And this one's a little harder because it's x. G of f would be f of x. I'm putting an f of x everywhere there's an x. I'm showing a little more work here. I hope I don't mess you up. F of x is 2x plus 1 squared minus 2 times 2x plus 1 minus 4. I just put it everywhere there's an x. And then I work it out. 2x plus 1 squared, I have to write that twice and full it. That'll be 4x squared plus 2x plus 2x plus 1 and then minus 4x minus 2 minus 4. So combining the like terms, 4x squared, 2 plus 2 is 4, minus 4 is gone, and then 1 minus 2 is negative 1, minus 4 is negative 5. So it's 4x squared minus 5, and that's all for that one. That's f of g of f of x. And then the last thing asked me to do f of g of 4. Well, this is f of g of x here. I just plug a 4 in where the x is. So f of g of 4 would be 2 times 4 squared minus 4 times 4 minus 7. And I know I did not leave you enough room. I'm so sorry. 2 times 16 minus 16 minus 7. 32 minus 16 minus 7. 16 minus 7. 9. And I'm going to stop there.